Good morning. This is the PLC professor, and our little project for the day is to build a training unit identical to the one that I used to develop the three manuals that I market on the plcprofessor.com website. If you've not seen those three manuals, there's a basic manual, an advanced one, and advanced 2. And inside of these manuals, everything is done step by step, printed in full color. And the reason there's 3 manuals instead of just one is because it was quite a large book to print in color, and maybe everybody doesn't want to do the more advanced stuff. So I broke it up into 3 manuals: basics, advanced 1, and advanced 2. In the original marketing, I put disc in the back of each manual. Matter of fact, there were so many videos for the advanced 2, it took 2 discs. But these video clips went over the lab projects and discussed not just the results, but some of the instructions in more detail. All of these videos now are available free on YouTube. Prior to doing the lab projects, though, there are half a dozen lectures that I originally marketed on these 2 discs. They are also available free on YouTube. So by all means, go to YouTube and watch these lectures to your heart's content. I would prefer that you watched them on YouTube. I mean, I don't mind you downloading them because I would certainly download them if I was going to use them, but the more you watch them on YouTube, the more hits my channel gets and the easier it is for people to find it when people are searching for the first time. So our project today is to build a training unit, and to do that, first of all, we need a PLC, programmable logic controller. Any PLC might do, but for this set of training manuals, the I/O addressing and the internal addressing, the pointers, the tags, whatever you want to call the memory locations, in the manuals use RS-Logix 500. This is the least expensive processor that you could program with RS-Logix 500. And the manufacturer of this PLC has made that software available free for anyone to download off their website, but it will only program the 1000 series, and there's more than just this one in the 1000 series, and 1100s. So that was the purpose of picking this processor. Originally, when I created these lab manuals, it was because when I was doing a lot of training for distributors, I found that there were a lot of electricians and technicians and even engineers who were there on their own dollar because their companies would not pay the price to give them the training, so they were paying out of their own pocket. So I thought, how can I come up with something that's bare bones cost-wise, but still a full and complete training package? So that's how I come up with this. There's a dozen lectures that last, I don't know, 5, 6, 7 hours, and then each manual has quite a bit, I don't know, another hour or 2 in each manual of lab wrap-up sessions. So we need this PLC, we need a box to attach it to, we need 2 440 nuts and bolts to attach the PLC to the box, we need 6 selector switches to simulate inputs. Remember, there's 6 inputs on this PLC, 6 selector switches. Now don't be confused, there's more than enough screw terminals here, but you notice the last 4, I don't know if you can read it, but it says not used. And then the first 2 say not used. And then of course on the output side, you've got some isolated contacts. All 4 of those are isolated. See, there's 2 terminals for each output. You've also got terminals for your 24 volts DC in and ground. So this inexpensive unit does not have a power supply from public power to 24 volts DC. That's what this power adapter is for. Now these I buy on on eBay, fairly inexpensive. I've never paid more than $12 for one. This says Kodak, and its input is 100 to 120 volts AC, 50 or 60 hertz. And the output, which is the most important, 24 volts DC, 2.2 amps. You don't need 2.2 amps. 500 milliamps will be enough for this project. So you can buy a smaller adapter. Sometimes they call them wall warts because they plug right into the wall socket, and then they have a cable that comes over. However, buy your adapter first before you go to the electronics parts place to get the power jack that you're going to mount in the box, because you want to make sure you've got a good mate. So we've got a PLC to mount, 2 nuts and bolts to mount it to the box. We're going to drill some holes, put in 6 toggle switches, a power jack, and then we're going to wire it up. To wire it up, you're going to need conductor. This is MTW, machine tool wire. You'll recognize it because it has a real satin kind of soft finish, and it's very soft, pliable insulation. It's very easy to work with. This is THHN, which is really very, very durable. It's meant for dragging through conduit, and it has a real tough outer skin that's real shiny. You can see in the video clip how shiny it is. This will work, but it's very tough to work with, and it doesn't look real good when you're done. What I'm going to do this time, even though I'm a stickler for color code, and you really should use blue for DC, we don't care for this project. I'm going to use a length of multi-conductor cable, and I'm going to strip the insulation back and use the wires more or less individually. Now it looks like you have green, red, blue, orange, black, and white. Well, you really have orange with white, black, and I'm sorry, green with white spots, green with black spots, and then plain green. And then you have red with the white spot, plain red, and then red with a green spot. So all of these conductor or insulation colors, green, red, blue, orange, black, and white, have 3 versions of each. So each of these is individually identifiable. The reason I'm doing this is because I can just write down what color of conductor went to each of these switches, so I know what terminal to drop them on here without using wire markers. Okay, to drill holes in this box, and by the way, there's 2 ways you can mount this. You could mount it to the lid, or I usually mount them to the bottom. That way I can take the lid off and all of the wiring is inside of this part of the box, and this is now the bottom. And if you want to be clever, you can go to Lowe's or Menards, any hardware store, and get little peel-off sticky rubber feet to place on here. Don't put them over the screw holes in case you want to take it apart, but to put 4 feet on here so it'll sit nice and not slide around much. Now remember, the idea here was to make this whole thing small enough to put in your computer bag with your laptop and your manuals and go sit at Panera Bread. You need 2 outlets, you need a duplex, because you got to plug in this and you're going to plug in your laptop. You got a good battery on your laptop, maybe you don't need 2 plug-ins. You're also going to need a cable to go from your laptop to the PLC. Now this PLC has 1 serial port right there. And that takes that round DIN connector. The other end is meant for an RS-232 port. However, a lot of laptops these days do not have RS-232 ports, so you need a USB to RS-232 adapter. Now this is the adapter right here. This is just a standard USB cable. You can buy both of these together online for about $30. If you go to www.plcprofessor.com, go to the useful links page, you will find a link there to a vendor who sells those cables. Or go on eBay, type in Micrologics cables, and you'll still come up with the same cables for around the same price. Now, to mark the holes in this box, we're going to use a straight edge. I prefer steel because I usually just scribe a mark. However, this is very cumbersome, so you might want to use a smaller straight edge and then put a mark halfway up the box in 2 places, and then take and draw a line across the 2 marks, and then use tick marks for the individual locations for the holes for the switches. Now, when you're mounting these switches, you want them far enough apart so when you're installing them, you can spin them and they don't run into each other. So don't put these switches real close together. Also, when you're doing your labs and it's sitting here like this, and you're operating the switches, you want them far enough apart where you're not accidentally hitting the wrong one. 5/8 to 3/4 of an inch apart is perfect for these micro toggle switches. However, if you don't want to do any soldering, which you're going to have to solder if you're going to use this kind of devices here, you don't want to solder, you need a larger box, and then go to either Radio Shack or any electronic supply place or even an automotive parts place and buy 6 larger toggle switches that have screw terminals. You can, well, there's 2, this is definitely soldered, but you can get toggle switches that have larger blades that you can slide on crimp connectors, or that have screw terminals so you can screw your conductors to the switches. You may still have to solder to these 2 connectors right here in order to bring in the power adapter. Something else I want to point out in case I forget later. One of these is positive and the other one is negative. Make sure that you plug this in and use a meter to measure to see which one's positive and which one's negative. If you get them backwards, you can always switch them here with the wires that come up to your inputs and your power for the box. But it's kind of better up front if you make them identify them and wire them up correctly the first time. Okay, what we're going to do now is we're going to take the box and we're going to go drill the holes in it, and then we'll come back and go to the next step, which is soldering. If you've never done soldering before, I will take a little extra time to talk about soldering. Like I said though, you may want to use larger toggle switches and just use screw terminals. We'll be right back. Okay, now we want to solder a conductor to each switch. To do that, we're going to first strip a 1/4 inch off of the end of the wire. Then we're going to take and twist it to make sure that it's nice and straight. Then we want to tin the end of the wire, and to do that we take and we hold the wire on the soldering iron, and then we add solder, and we hold it there long enough to make sure that the solder is wicked up into the wire, so we have a nice tinned wire. Then we're going to take and we're going to tin the pin on the switch, and the key when soldering is you have to get the wire hot enough to melt the solder. I mean, the solder will melt against the tip of the soldering iron, no problem, but you got to get the wire hot enough, the conductor hot enough to melt the solder, and the pin on the switch hot enough to melt the solder in order to get it to stick. Now once you have solder on both of those pieces, then it's just a matter of heating up that pin and then pushing that wire through that hole that was in that pin just far enough that it's through, and then hold it steady. I have a hard time holding it steady until it hardens. Once it hardens, you can take and pull on it to see if you have a good connection. And then the last thing you want to do is you want to take your side cutters and trim off any excess of the conductor that was sticking through the hole on the switch. And you want to do this to all 6 switches. Okay, now we're going to mount the switches into the box. I've already got 5 of them mounted. Notice that the conductors are on the bottom. So I take one of the switches and I put the locking nut all the way to the bottom of the shank, and then the locking washer right in front of it. Then I slide it in the hole with the conductor that we soldered on the down position, and then I take the other nut. Each one of these comes with 2 nuts and a locking washer. I put it on there finger tight. Then I take needle nose pliers, and when I'm holding the switch vertical inside the box, I take and grab the flats on the nut and turn it with the needle nose pliers. You might want to do this with a wrench, and you're bound to put a few little scratches on the box. Okay, there we've got all 6 switches mounted with the wires to the bottom. As you can see, they're not exactly perfectly straight. It's not going to really matter because the switches are still going to look okay from the top side. See, they still look fairly well lined up. You can see they're off just by a little. It's still going to look pretty good. Okay, now we're going to make the common conductor that goes across all 6 switches. So I've stripped off about 5 inches of insulation, then I twisted the wire so it's nice and mechanically stiff. Now I'm going to take and tin the wire the full length. And I realize that if you haven't done this before, this probably looks like it's a big deal. Well, you don't have to tin the whole thing. Now, actually I did a really good job there. I'm quite proud of myself. Been a while since I've done this. So now I have a fairly stiff piece of wire that I can run across all 6 of the switches. So now I'm going to mount this wire in there, and to do that, and I probably should have done this while the switches were still out of the box, I need to tin the middle pin on each of the 6 switches. So you go in and heat up the pin just enough to melt the solder. Now you may figure out a better way to do this than what I'm doing. So once you have them all tinned, so your shorting conductor here, your common, what you want to do then is stretch it across all 6 switches, and then solder it in. So I'm holding it in place, and I'm going to heat up the one end, let it solidify, so now it's stuck in there. Then I'm going to take and move down to, say, I'll skip one. Boy, that got hot. So you might want to use your needle nose pliers to hold that in place. And we'll do this one. And we'll go back and do some of the others over to make sure that they were a good solid solder joint. Now when you hold on to it with the needle nose pliers, you're actually pulling heat out, so it's going to take a little bit more work. Now see, I didn't put enough solder on this section of the stripped off wire, so it wasn't really tinned. So see, it didn't stick real good. Now it's good. So now you can go back if you want, now that something's holding it in place, and you can ensure that each of them is a good junction. So there we have the common wire. I see this one's sticking up just a little bit, so I'm going to take and heat this back up and hold that down while it cools. Okay, it's always a good thing, sorry for jumping around like this, this is very difficult, to take and then grab each one and wiggle it to make sure that you have a good solid connection. So you checked each one of them. So at this point we have 6 switches, each with an individual wire, then a common. If you looked at the circuit in the manual, you'll see you need to bring plus 24 volts DC to all of the switches, and then that plus 24 is switched through the switch to the PLC input. Okay, I fastened the PLC with those two 440 nuts and bolts. However, I guess I should say that it would be a lot easier to use a larger box. Use the next size up project box. This is a 4x6x2. I don't know what the next size up is, but notice I had to take and cut off a couple, see that boss right there? I had to cut it off so that I could put the nuts on. And it is fairly cramped working in there. It's possible, and if you want a nice small compact result, then by all means use this size box. Next thing I'm going to do is I'm going to take the conductors and I'm going to stuff them through the hole I drilled to run them up to the PLC. So you see they're coming through a hole right next to the inputs, and I'm missing one here. Saying he should have 7 conductors. Oh, I'm still missing one. I'm missing the white one. So thread that through the hole there. And we got all 7 conductors coming through here. So then we turn it over and we carefully hold on them one at a time until we have something that looks fairly neat. The white one can go a little more, the orange one can go a little more. So you see, having these individual colors helps. So if you wanted to be real neat and tidy, wanted to tie wrap all this, I suppose you could do that. Matter of fact, I probably will put one tie wrap right here. I'll put one tie wrap as a strain relief here, and then one outside to act as a strain relief. Okay, so now we have the inputs wired up inside the box. The next thing we have to do is we have to wire up the power connector, the power plug, and we have to put a red and a black wire on it, mount it in the box, and then bring it through here for power here and around here to power the switches. Okay, here we are ready to solder again, and I have the power plug held here in the little clamp, and I'm going to put enough solder in here so we got something to work with. You don't want to get that too hot because there's a plastic insulation between the center pin and the outer, and if you get it too hot, it'll melt the plastic and ruin it. Now I'm going to take and move this over here, and I'm going to tin the end of the wire. And I'm going to do the same thing with the black wire. Okay, then I'm going to take and I'm going to lay the black wire on the outside connector, Then hold it there until it hardens. So it didn't actually go through the hole. Technically, you're supposed to put the wire through the hole, bend it tight, and then solder it to make a good mechanical connection first, then a good electrical. So do as I say, not as I do. And this one's going to go in the center. Now, while you weren't looking, I checked the polarity on that DC adapter. I knew the center is positive and the outside is negative, and that's normally the case because they want to improve the noise immunity of the plus side of the power supply, so they put the positive on the inside and the negative on the outside. Okay, now we've got the power plug wired up. So we can now we'll put the washer on it. So we have the washer behind the power plug, and then we'll thread it through the hole. And then, of course, the nut also has to be threaded on the wires, because the nut has to be on the inside of the box. So you can't see this very well. It's very difficult shooting some of this. Maybe that's better there. You can see I'm tightening up the nut on the back side. Now, I made my hole a little large. I used a 1/2-inch drill bit, and it should have been less than half and more than 3/8. I didn't have anything in between. So I should have drilled at 3/8 and then filed it out, or used the drill bit in a motion like this to slightly enlarge it so that would slide in. So now that we have this in, we need to tighten it down yet, but then we're also going to take and fish the red and the black wire through the hole, and it'll go up to this side of the PLC. The next thing we want to do is we want to use your meter, if you have one. I'm trying to set that so you can see. And then you take, we're doing resistance here, so we're looking for 0. Yeah, it looks like I might need a new battery. This meter. That's close enough to 0. So we're going to take and put one lead on that center shorting wire, and then we're going to, by the way, make sure the switches are in the down position. So all the switches are off. So we put one of our leads on the center, and then we touch each of the soldered wires on the bottom side of the switch one at a time to make sure that there's no short. Then we flip the switches up, and we repeat that, and each one should show conduction. I mean, if these switches aren't any good or we got a short, we don't want to go any further. The next thing we do is the red and black wires that we ran from the power connector through that hole, we want to attach those to the prospective pin. So red goes to positive right here, so you slide it under the pad. Of course, you cut it to the length you want, strip it, slide it under the pad and tighten it down. Do the same for the negative. Try to keep the screwdriver out of the way of the camera. Not doing a very good job because I'm right-handed. Snug it down pretty good. Don't reef it. It's not necessary. Okay, the excess wire you can slide back in so it looks fairly decent. Now we're not done here. I did tighten them down. I'm going to loosen them back up now because we have another conductor to put in here. Because we need to bring the power from this side over to this side to power the switches, the inputs. So we strip off a 1/4 inch on each of our conductors, and then we slide one under the black side, slide one under the positive. Try not to create any flags, little conductors that are sprawled out from the connection. Okay, now we can take this black and red wire, stick it back in the same hole that the other two came out of, and then go up the other side because remember, we want to run these over for the inputs. Always leave a little slack inside the box. I mean, these wires aren't going to show anyway, so why stretch them tight? Now on this side, we're going to take the first two terminals that are unused, and we're going to make the first one positive. So again, we take these two wires, we cut them off, then we strip a 1/4 inch. And we're going to end up putting two wires under each of these as well. So for right now, we'll just slip one under there and snug it down. And slip one under here and snug it down. Okay, so we brought the DC power in from here. We brought it over here to power the unit, and then we're taking the same 24 and coming back over here, and we're going to use these unused connectors here as marshalling points or landing points for the positive and negative, and then we're going to wire up the switches using this power. Okay, if you look, we ran the red and the black up. They came from the other side where the 24 volts DC came in. They came through the box over here to the two unused terminals. Then I looked to see what color I had soldered to the bottom side of each of these switches and put them on input 0, input 1, 2, 3, 4, and 5. Notice I skipped DC common and DC common. So we still have this one red wire, which is the plus side of the switches. So this will need to go to this positive, and then this negative side here, the black, needs to be jumpered to this DC common and that DC common. Okay, the next thing to do is what I call the smoke test. We want to see if there's any smoke in here that we can let out. So I'm going to plug in the power adapter, and if you see a green LED there, then you know you're good. Okay, so we got the PLC powered up, and then flip the switches on in order, and the switches work. So if there's power to the PLC and the switches appropriately turn on their prospective input LEDs, then you know you're good. The other thing that I wanted to point out was, remember we had two wires over here on this side, two blacks and two reds. So we brought DC power to this side first, then ran it through the inside of the box over to this side to here. We also took the red switch from the wires, the common, hooked it to plus, and remember the negative from over here came over to here. We jumpered it to the DC common to the DC common. So if you happen to have the manual, you can see right there how the switches are connected. The plus goes to the common on the switches, then the switches individually go to the inputs, and then the negative goes to the DC commons. And of course then we have power coming from the other side. So in this diagram we brought the DC power up to the input side and then took it over to the actual power terminals for the PLC. The one we just wired up, we actually brought the power in here and then ran it over to that side. It's all the same though. Now this one shows a regular power supply like a Sola or an Allen Bradley or whoever, Phoenix, whatever. It's not necessary to buy a high-end power supply. Those are at least $35, $40, where the power adapter that we used is only about $10, $12. At this point you can go ahead and tidy up your conductors. Okay, now you can see that we've tidied up the wires a little bit, and we used a tie wrap here, and then we used one there as a strain relief. We used one over here as a strain relief, and we kind of pushed the excess back into the box. And then in the box you can see we've used one big tie wrap there to act as a strain relief on this side. So even the inside looks pretty neat, considering that we did not go out of our way to cut any real special links. It's not really worth your time. You can always stuff the excess. You got plenty of space down here in the bottom of the box. The last thing that you want to do after you straighten up the wires is you want to check your LEDs again and make sure that you got power and all 6 switches come on and off and you've got power. So this is your completed demo here. The only thing left to do is to put the bottom on and then add feet if you want a feet. So in this broader view here you can see I sit and do a lot of work on course development for different control packages. Over there at the far end of the table, that's a Control Logics with 2 L63s and a miscellaneous I/O modules. And then a Compact Logics that I'm going to do a little work with. So far on PLC Professor, it's been strictly RS Logix 500 and related products. So remember, you also need a cable, and one end of that cable is this round DIN connector that slides in like such, and the other end goes into your laptop or through the RS-232 adapter to USB into your laptop. So that's the finished product. In the manual we showed you another way to do it. You can buy this circuit card, and it actually has, it looks like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 switches on it. And this switch card is made for, it'll work with this one. You can only use the first 6 switches, but it'll also work with a larger micrologic. So, and you can also buy this in a 110 volt or 115 volt format. So all you do is wire up 115 volts to it, hook the switches in, and away you go. What we've done with this is the least expensive format, power adapter and PLC for creating that kind of a trainer. So thank you for your rapt attention.